In this lesson, we're going to look at how to use the array tool to create a spiral staircase. Now, since the end of the last lesson, just to recap what I touched up on, is I had gone and continued with what I was talking about in the last lesson, and I had just basically gone through a process where I'd tweaked and copied and mirrored and just basically sized all of these window units. I had to go and make each window leaf about 200-300 millimeters longer, just so that I could get a longer leaf, which meant less amount of leaves, which means that the total width was reduced by about 1 or 2 leaves. I also managed to get the center point between these two columns to basically line up with the center point of these two fixed leaves. And what that meant is that I've now got a relatively clean looking facade where I have 4 moving leaves that basically slide and stack here. I have 3 here, and I have a total of 5 along this long facade. So 5 is quite excessive, but if you really want to achieve that complete openness that you're going to get around this corner, then that's really the way you want to go. This might be too extreme for certain houses. I think going anything more than 2 or 3 moving leaves is already quite a lot for these type of stacking doors. So this will already be quite a installation to go and add this amount of rails. But this is quite an extreme house, and why not? What I'd also done is I'd tweaked the stairs just slightly, basically doing the same thing that we did when we created and edited them in the last video. I had also gone and copied the glazing to the bedroom side, and I'd basically tweaked the glazing here to basically include the same type of sliding system that we have over here. Difference is that this one will be a smaller window. It won't be full width or full height rather, as it is in the lounge. Anyway, this lesson is all about the spiral stair. Now you can also call it a helix, even though that is what the actual form is correctly called. And a good amount of information can be found on how to actually design these spiral stairs. Now I could spend hours and hours talking about all the different calculation methods for your tread, your risers, and all of that, but I'm going to focus on just getting it out as quickly as possible. I'm not going to fine-tune the heights or the dimensions too much. I just want to get the principles rolling. If you do want to find out a good amount of detail about stair design, you can look in the Bible of all standards, which is your Newfit book. It's quite a large, thick book that basically takes you from A to Z. So every time I need to find out any details about how high or how big a stair tread should be, or how big anything should be in a building or any type of situation, they will include everything from stadiums to gardens to all sorts of details. It's all in this single book. So that is really fantastic. Get it if you don't have it. If you're doing architectural work, I can definitely recommend it. So when you start doing your staircase design, the first thing you want to ask yourself is, first of all, how many levels are there, and especially what is the height from floor to floor between the levels? That is the most important thing to decide. Now, in a regular residential building such as this one, we only have the ground and the first level. Let's just turn on the image underlay here so that we can see. Basically, that staircase is going to be located right here. And just as a bit of a design feature, as a subnote, is we have a pond of water that the staircase will be floating above. So what we want to do is we want to start the staircase round about here. We come into the building and we're going to walk up in this direction, and we're going to try to make the staircase end roughly about here on the level above. And as you walk out, you're basically going to be walking over water. Now perhaps the staircase could even be in glass, or it could be something quite fancy, so you get this full experience of transparency, since that is the general feeling and the theme that we want to express through this house. Transparency into the garage, transparency out of the dining room, out of the lounge, transparency through all of this water that's going to be falling over the edge, and basically that is going to be the feeling of openness that we want to work on. That's the design theme. So with the staircase itself, what you want to do is, as I mentioned at the beginning, decide on the height. Now, it does help to create a little CAD section where you draw your floor level, then you have a look at what is necessary in terms of structure, ceiling, aircon, all your other services, your floor, the way that your floor is composited, whether you are going to have any gaps in your floor. In other words, are you going to have a raised timber floor, or are you going to have a deep dropped ceiling? How many millimeters do you need for clearance of all your structure? All of these thoughts have to now be brought into play, even though you're just at a conceptual stage of your house. But getting this right is quite important. Obviously, you can go and edit your staircase later, but it does help to know more or less. So just to be safe, what we're going to look at doing is we're going to do a a 4-meter floor-to-floor height. So this is quite generous. It's a little bit more than most houses would have, but since we want to have very large, beautiful openings, we're just going for quite a big height. So I'm going to do a tiny section here just to demonstrate what we're doing, and we have a height of 4 meters, so you can just double check that. DI, from level to level, we have 4,000 millimeters. So then what you want to know is more or less what is your average tread riser going to be. Now a rough distance or a rough height of about 160 to 170 to 175 is generally okay. You can have a look at all of those ratios in the NeuFit book itself. So if we take this distance of 4,000, you can bring out your little trusty calculator. You can then type in 4,000 divided by about 165, and then you can get a number, so 24.2. So since I want to have quite an easy-going staircase, I want the treads to be quite large. Let's say that we want to have this 24 or 25 stairs. It doesn't really matter, it's going to be more or less the same amount. So basically you then take your 4,000 millimeters, you divide it by, let's say, 24, and you see that you get 166. Then you make sure you go back to your ratios and you calculate whether 166 is going to be an adequate or a sufficient tread riser in the type of situation that you're going to use it for. If you're doing an emergency staircase or if you're doing an outdoor stair, all of those stairs will have different riser and tread height, so make sure you get that right. Anyway, I'm going to focus on rather the design of the building instead of getting all of the technical details perfect. And I'm going to be dividing my stair 24 into 24 treads or 24 risers. So the next thing is I want to decide what angle I want those risers to fill. Now I don't want to go 360 degrees, which means that I would start my staircase here and then basically end up at that same point on the level above. I want to leave a little bit of a gap, so it kind of makes a V. So let's say that we want to fill up 3/4 of that circle, so that's going to be 270 degrees. So what you can do is you can start by making the total width of your stair, and basically you're just going to start drawing the outlines in place. So let's say that we want a stair that is roughly about this size. We can actually go and size it up as we go along. So let's say I want something that is, how wide is that going to be? Just measure on screen first of all what that width is going to be. So that says 3.7. So let's make a size that roughly matches that. We want to leave a little bit of a gap so we get some transparency happening. And let's now go and make an inner circle by offsetting that outer circle by 1.2 meters. So we'll end up with a little bit of a hole in the middle, which of 1.4 meters in diameter. So now what you're going to do is you're going to draw one of those treads in place, and I'm going to move it by 45 degrees. So rotate, select the object, specify the base point, and then we're going to rotate it in the minus 45 degree direction. So that will turn it clockwise. So basically the stairs are going to start here and they're going to basically go up, and we're going to see what the tread distance is if we end up at 270 degrees. So now to do the array, we do the function just the way we did for the window frames, is we type in array, or you can also go to your little toolbar, and I'm going to select the object, and I'm going to choose polar. You can just click on it, and basically I'm going to choose that center of rotation being there. Angle to fill is going to be 270 instead of 360, and the items are going to be 24 instead of the 6 that was the default. So now what you want to do, you can also ignore this yellow line that is just a center line. We can also now match properties for the center line, make it dashed. Perhaps we make it a different color, so cyan or something. And now what you want to do is you want to measure the average tread roughly just center of the middle, and you want to make sure that you get about 250 to 350 in terms of size. So at the end we have 370, and around here we have about 207. So it's a little bit narrow on the inside, so you may want to go slightly bigger. So one thing you can do is if you want to scale this up, you can just type SC enter, and let's scale it up slightly using the reference scale, just like we did at the beginning of the course. So by scaling it up, what you do is you still have your angles being the same, and you can now remeasure what it's like in the middle, and you get about 294. So actually if you measure just center of the just inside of the middle, you get about 253. So that's more or less fine. You may want to tweak it as you go along. Or you can also have a look at your standards and work out all the formulas. I'm not going to do that right now since it would push the lesson to a multiple lesson length, which I don't want to do. But basically there you have it. Now you have your staircasing plan, and what we're going to do once we start drawing our sections and our elevations, we can start looking at what this is going to look like in the other dimensions. So I'm going to delete that, and basically there you have it. You've got your staircase done, and in the next lesson we're going to continue with a couple of other formalities on this level, just before we then later in one of the next future lessons copy it across to the upper level.